Dear students, in this video we are going to discuss about how to develop the expressions for the deflection as well as bending moment at the midspan of a simply supported beam which is loaded with UDL throughout its span using Rayleigh-Ritz approach by considering the trial function as trigonometric function. Okay, so this is the given problem. A simply supported beam of length L meter is considered, which is constrained at both of its ends. So the vertical deflection is arrested at both of its ends. That can be taken as the essential boundary conditions, that is at x is equal to 0, y is equal to 0. Okay, at x is equal to 0, y is equal to 0, and at the end point, that is at x is equal to L, also a constraint is provided. So at x is equal to L, the vertical deformation is 0. So these are the essential boundary conditions for this problem, and the entire beam is subjected to W Newton per meter UDL, uniformly distributed load. Okay. So we can solve the problem using Rayleigh-Ritz approach. We all know that the governing differential equation for beams EI d power 4 y by dx power 4 minus W is equal to 0, which is applicable between the limits 0 to L. Okay, and an important thing, for following Rayleigh-Ritz approach for solving any structural problems, to frame the trial function we have to consider only the essential boundary conditions and not the natural boundary conditions. Okay, so the essential boundary conditions for the given problem is y of 0 equal to 0 and y of L equal to 0, and it is asked to use trigonometric type function as the trial function, displacement function. So we can consider the common trigonometric function y of x is equal to a sin pi x by L as the trial function. Okay, so now we can check whether this trial function satisfies the essential boundary conditions of the given problem. Okay, so when x is equal to 0, the trial function a sin pi by L into x is 0. So sin 0 is 0. The first condition is satisfied, that is when at x is equal to 0, y is equal to 0. Okay, then we can check the second boundary condition. At x is equal to L, the considered trial function will be pi L by L, that is a sin pi. Sin pi value is 0. So the second condition is also satisfied with the assumed trial function. So we can go with this trial function. Okay, y is equal to a sin pi x by L. So to solve the structural problem using Rayleigh-Ritz approach, we have to go with this formulation, that is potential energy pi is equal to strain energy U minus work done on the structure H. Okay, so we know the strain energy formula for beam elements. U is equal to integral 0 to L d square y by dx square the whole square into EI by 2 dx. Okay, so we have the trial function here. So to substitute here in this formula to calculate the strain energy, we have to differentiate the trial function y twice with respect to x. Okay, so dy by dx by differentiating equation 1 with respect to x. So differentiation for sine is plus cos, so a cos pi x by L into for pi x by L, pi by L. Okay, so simply a pi by L cos pi x by L. Then d square y by dx square is a pi by L. For cos, the differentiation is minus sign, so minus sin pi x by L into again 1 pi by L. So simply minus a pi square by L square sin pi x by L. Okay, so now we can substitute this in equation 2. So equation 2 becomes u is equal to ei by 2 integral 0 to L minus a pi square divided by L square sin pi x by L the whole square dx. Okay, so ei by 2 integral 0 to L. While we are squaring the terms, minus will get cancelled. A square pi power 4 divided by L power 4 sin square pi x by L dx. So the constant terms can be taken out. So ei a square pi power 4 divided by 2 L power 4 integral 0 to L sin square pi x by L dx. So for integrating the term sin square pi x by L, for simplicity we can use this expression to reduce this form. So sin square theta is equal to 1 minus cos 2 theta by 2. So the above term can be rewritten as 1 minus cos 2 pi x by L divided by 2 dx. This 2 can also be taken out. So ei a square pi power 4 by 2 into 2 4 L power 4 integral 0 to L 1 minus cos 2 pi x by L dx. So now we can integrate ei a square pi power 4 divided by 4 L power 4. So the integration for the first term 1 as x minus the integration for cos as simply sin. So sin 2 pi x by L divided by 2 pi by L. So that can be written as L by 2 pi into sin 2 pi x by L. Limits 0 to L. Now we can apply the limits. Ei a square pi power 4 divided by 4 L power 4 into, while applying the upper limit, so for x that is L minus sin 2 pi L by L, that is sin 2 pi, so that value will be 0 minus by applying lower limit So for the second term, while we are applying the lower limit, the value will be sin 0, 0. So simply ei a square pi power 4 divided by 4 L power 4 into L. So ei a square pi power 4 divided by 4 L cube. So this is the expression for strain energy for the given condition. Then we know the formula, general formula for the work done while uniformly distributed load is acting on a simply supported beam, integral 0 to L W y dx. So integral 0 to L W into y, the trial function we have assumed as a sin pi x by L dx. So the constant terms W a integral 0 to L sin pi x by L dx. So W a into the integration formula for sin as minus cos pi x by L divided by pi by L. So which can be written as minus L by pi cos pi x by L limit 0 to L. Okay. So the constant terms can be taken out. So minus WAL by pi into cos pi x by L limit 0 to L is equal to minus WAL by pi. Upper limit substitute பண்ணும்போது L and L will get cancelled. So cos pi value as minus 1 minus lower limit cos pi x by L. While we are applying the lower limit, that will be cos 0. So cos 0 value is 1. So minus WAL by pi into minus 1 minus 1 minus 2. So the H value is 2 WAL divided by pi. So now we can substitute the values of strain energy and work done U and H in the potential energy formula. Pi is equal to U minus H. So U is EI a square pi power 4 divided by 4L cube minus H is 2WAL divided by pi. So to find out the constant A, we can go with the principle of minimum potential energy, that is tau pi by dou A is equal to 0 for achieving the equilibrium condition. So here the dou pi by dou A will be EI differentiation for A square when we are differentiating the expression with A, 2A into pi power 4 divided by 4L cube minus here also for differentiation for A is 1L by pi is equal to 0. So EI A pi power 4 divided by 2L cube is equal to 2WL by pi. So the value of A can be written as 2WL by pi into 2L cube divided by EI pi power 4. So simply 4WL power 4 divided by EI pi power 5. So this is the solution for A. So already we have assumed the trial function for the given problem as y is equal to A sin pi x by L. So in this expression we can substitute the found out value of A. So the result will be 4WL power 4 by EI pi power 5 into sin pi x by L. But it is asked to find out the deflection expression at the midspan. So at the midspan x is equal to L by 2. So in this expression, in the above expression, we can just substitute the value of x as L by 2 to find out the maximum deflection. So 4WL power 4 divided by EI pi power 5 into sin pi into x க்கு L by 2 already ஒரு L இருக்கு. So sin pi by 2 value as 1. So simply y at x is equal to L by 2 as 4WL power 4 by EI pi power 5. On simplifying, 4 by pi power 5 will be 0.01 WL power 4 by EI. The standard formula for this case, that is when a simply supported beam is subjected to uniformly distributed load throughout its span, the formula for finding out the maximum deflection will occur at the midspan of the beam. So the formula for maximum deflection is 5 by 384 WL power 4 by EI. 5 by 384 is 0.01. Okay. So next it is asked to find out the expression for bending moment. We know the formula for bending moment, standard formula is EI d square y by dx square. So here for the assumed trial function, already we have calculated the value of d square y by dx square. Here is that minus a pi square by L square minus a pi square by L square sin pi x by L. So we have calculated the value of A as 4WL power 4 divided by EI pi power 5 into or pi square by L square sin pi x by L. Okay, so this EI and EI will get cancelled. Then L square L power 4 pi square pi power 5. So simply minus 4W L square divided by pi cube sin pi x by L. So again it is asked to find out the expression of bending moment at the midspan. So at the midspan x value is L by 2 minus 4W L square divided by pi cube sin pi by L into x is L by 2, sin pi by 2 value is 1, so the result is minus 4W L square by pi cube, which is 4 by pi cube is minus 0.129 W L square. The standard formula for the given case m at x is equal to L by 2 is W L square by 8, that value is minus 0.125 W L square. This is the standard result. This is the obtained result while we are following Rayleigh-Ritz approach. Thank you.